of what we did yesterday. So, to clarify, this whole section is on limits, and we're going to crank through it fairly quickly. You're going to have a lot. You have all the homework assignments. The first one's due on Monday. Okay, it's all visual or using your calculator. Okay, visual or using your calculator, and then we're going to start up on how do you do these without a calculator. Okay, how do you do them algebraically? That's what comes next. So a little bit on notation. Again, I'm going to wrap up. Let's just do one of them here together. This is the function f of x. So if I were to say to you, if I were to write this down, okay, you should be able to get an answer for each one of these. And I need you to be able to speak limit. Okay, you have to speak limit. Okay, so based upon what we did yesterday, everybody get an answer to the first one. Okay, look at it, look at it, look at it. All right, raise your hand if you have an answer. Just raise your hand if you have an answer. Okay, I'll just wait till everybody's got an answer. If you were gone yesterday, we're just going to wait until Jenny's got her answer. No. No. Okay, count of three, yell it out. 1, 2, 3. Okay. Answer is 1. The reason is because the way we read this, okay, you must understand the language. The limit of f of x as x approaches 1 from the left is 1. This is the notation for it. The justification is this. As we approach x equals 1 from the left, we're only looking at the y values, and we're looking at what is the expected value if we were to actually hit 1. We're not looking at actually what happens at 1, just as we get infinitely close. And it looks like if you were a betting person, the answer would be 1. Okay? All right. Somebody say this. Raise your hand if you think you can say this correctly. Okay? If you think you can say this correctly, I'm looking at language here. Can you say it? Harry, give it a try. Good. And the answer is 1, is correct. Because we're coming in from here, and it's very good. So it looks like it's going to be 1. No, you can say, I'll say this one now. The limit as x approaches 1 of f of x then is equal to 1. Those two can be interchanged as they are. Okay? Does that make sense? Yeah. If it is from the left and to the right, and then this, we don't have to say if it's from the left or the right. These two are what are called one-sided limits. And they are only used to help you get the real limit. This is the real limit. That's going to be your final answer. But there are times where you may be asked that individually. But you can only determine this if you know both of these. Okay? All right. Everybody get me an answer and write it on your paper. I want to see it like this for both the 2 and the 4. Do the left one, the right one, and then we're going to have x approach 2, and we're going to have x approach 4. Okay? Write it out like this so I know you know how to write your limits properly. going to be very picky about how you write things. Yes? Mm-hmm.
Is that like what it would sound like? Well, just for the, like, is this?
Mm-hmm. That's how it will go, and the answers are correct.
Okay.
Yes. Now, what if your mom says no? We'll have that, the box thing, yeah. We'll put the rectangles. Yeah, right. Right. Okay. So your notation should look exactly like this. Okay? Look at it carefully. This is exactly how it should look. And then let's get some answers. What's the first one? 2 is correct. The second one? 3. Answer here does not exist. Okay, that's how we say the limit if they are not equal. Okay? They both must equal to get there. Okay? And so then the last one is here. Never mind that. Okay, answer to the first one. 2. Answer to the second one. 2. Answer. Okay. So let me ask you this. If we know this, then what is this? I'm asking this question now. According to this, what is the answer to this? Do I hear a 6? No? Oh, my bad. Jeez. This is what I meant. Yeah. Okay. Because we were looking at 4, okay? Yeah. So f of 4, okay? F of 4 is undefined, okay? And the reason is that there's a hole here and we don't see any other points there, okay? This is what we call the function. What would be the functional value? It's the functional value. It's what the y value that you get out. That is different than the limit. Okay, sometimes they may be the same, but they don't have to be. There's no reason that they both have to be the same value. Okay, so functional value is different than the limit value. Okay. All right. Now I expect you to be able to start doing this pretty quick. Okay, so let's do another one. Okay. Don't say it out loud. This would be like about 5 seconds to figure out what the answer is. Okay, 3, 2, 1. Does not exist. Okay? Oh. Yeah. Okay. Now, remember, the limit is always whatever the final answer is, okay? So in this case, if I say to you, what is the limit as x approaches 4, what I'm really saying is, okay, do the left-hand limit, do the right-hand limit, and tell me what the result of that whole thing is, okay? So if I say, what is the limit as x approaches 4, you say, does not exist, because there is no answer here. But if I said, what is the left-hand limit, you would say 3. If I say, what's the right-hand limit, you say 5. But if I say, what is the limit as x approaches 4, without a left or a right, then you say, does not exist. Okay? All right, next one. Oh. It'll be our little secret.
I mean, I got it. I just read it as
Okay. All right. You're gonna jot down three. You're gonna jot down 4 answers here. One is for the limit as x approaches -4. Okay. So we'll see if this actually does work here. Yes, just the final limit. I only want the final answer. So we're going to do these 4 points at -4, at -1, at 2, and at 4. Get me 4 answers. All right, let's have some participation here. Raise your hand. Who has the limit as x approaches -4? Say it again. Does not exist. Do you agree?
Yes.
Little side note, what's the left-hand limit there, Bailey? Good. What right-hand limit? And those two don't match. Okay? You should be good with this, and then we'll go quick. All right, next question. What is the limit as x approaches -1? Tim? 4. Okay, that's correct. Left-hand limit, right-hand limit. Okay? This one is also the fact that if I said what's f of -1, it's also 4. Functional value actually equals to it. That's actually something magical.
Okay.
If the limit exists and the functional value equals the limit, then the function is continuous at that point. If the limit exists, in this case it's 4, and the functional value is 4, then that actually means the function is continuous at x equals -1. It's continuous right here because I'm not going to have to pick up my pencil if I go from the left or from the right when I hit 4, or I hit the -1. Okay, we're going to delve into that a little bit later. Okay, third one. As x approaches 2, Bitsy, does not exist. Left-hand limit, right-hand limit, and we're good. And finally, limit as x approaches 4. 2. Left-hand limit, right-hand limit, also 2. What's f of 4? Undefined. Okay, does not exist. Because there is an undefined value, this is discontinuous at x equals 4. Look at, there's a hole there. Yes?
What if the graph just doesn't approach it from the outside?
Oh,
Like
where
if
it's
at
just,
-6, yeah.
great question. The classic case, the question that she's asking, I'm thinking, is like, what if you have a square root?
Yeah.
Okay, so a square root function that's maybe shifted over 1. Okay. In this case, you cannot do a left-hand limit. Okay, there's no domain values. If this is the case, then the right-hand limit is the limit. Make sense? The right-hand limit is the limit. So in this case, the limit as x approaches 1 is 0 because it's the right-hand limit and there is no left-hand limit. Good question. Okay? Yes?
But what if we asked, like, what was the limit is actually from 0 to 6?
Then that would just simply be, it just, there is no value whatsoever. Because there's no way to approach it close enough. Right. Does not apply. Okay. Go home. Yeah. So that's that. All right. This is what the majority of your homework assignment is on. So what we're going to do. For this one? Sure.
Would you just do a few?
Exactly. Piecewise for each one, whatever it depends, that's where it gets it. Okay, couple of quick comments. Catching up. So let me ask you this. Now remember, when you answer true or false questions, there's no sometimes, okay? If it's sometimes true, then it's a false, okay? But true, on a mathematical true-false, means that it's true all the time. There are no exceptions whatsoever. If there's only one exception, it's got to be false, okay? All right, so what's the answer to this? False. False. Why? Could be a hole in the graph. We understand that this could be this situation. And this is my g function. Look at that graph. This is what we would say is a counterexample that proves that this is false. Because we just found one scenario, hey, if it's this, then g of a is actually undefined. Okay. So keep this, when you're looking at limits, we've got to be really, really careful. If I flipped it around, is it true now? Okay, everybody thinking, is this true all the time now? Or is there a possibility that it could be false? And if it is, whammo, it's false. Kendra, what did you say? Okay. So if g of a is equal to k, what I can say is let me move k, and then now we have this scenario. G of a is equal to k Does that force the limit as x approaches a of g of x to be k? And the answer is no. This is a counterexample that shows that it is not true. Does that make sense? Okay. All right. I am going to cut you guys slack today. I'm going to let you work on your homework so you don't have to do it for the weekend. And tomorrow, on Monday, we're going to start jumping up on the very next thing. Even though it's homecoming week, we're going to have to do a whole bunch of stuff.